Okay, here's the thing. I wanted to have an ultimate media center at home for a while now, both for playing retro and modern games from my Steam library. So basically a Steam machine, but I have a problem. At the time of making this video, it doesn't exist yet. So I had a plan. You see, Steam machine is basically just an ordinary PC underneath running a Linux-based operation system. So it shouldn't be that hard to make one, right? Well, about that. The last console I owned was released more than 25 years ago, the Sony PlayStation 2. I really never saw the reason to buy another console, because all the games I played were either on PC or simply didn't interest me. But sometimes you just want to relax on the couch, get comfortable, grab a controller and play something casual. So when I saw Valve is going to release the Steam machine, I got really excited, but I cannot wait that long. Since they haven't announced exactly when their PC console will be released or how much it will cost, I decided to build my own. The plan was simple: buy a cheap PC and turn it into a small factor system, similar to Steam machine. But it's never that simple, isn't it? This is my old computer that I used to use as a media center connected to my TV. Of course, my wife really disliked this big white box because it doesn't fit the room design, and I cannot argue with her. It really do look terrible in this room, and I think the time has come for it to leave this space. After searching for a while and seeing how much all the necessary components will cost, I realized that my plan has to change. The parts definitely weren't going to be new for this project. So I started moving on to browse second-hand listings. And after going through maybe 100 or thousands of listings, I realized that people have completely lost their minds. They want almost $800 for a 10-year-old system, which is way too much in my opinion. Still, it's cheaper than buying a brand new, older generation components from the store with today's prices and all. I originally thought that I will be able to build a Steam machine for less than Valve planning to sell their own, but now I can see that I was very wrong. When I had almost found something that would suit me, even though the systems themselves weren't very powerful, they were exactly what I needed. But there was still a problem. Almost everyone wanted me to pick them up in person. For some strange reason, no one was shipping them, or they simply refused to send them. That didn't work for me, because the closest PC that fit my needs was about 16 hours drive away. I definitely not driving 16 hours just to pick up a 10-year-old computer, especially when I would even use all of its parts. Most of those systems were ATX format, which means a big case. My plan was to build much smaller Micro-ITX system, somewhat not too far from the original Steam machine size, roughly 16 by 16, that's centimeters. Realistically, I only need a CPU, RAM and GPU anyway, since Micro-ITX platforms weren't very popular at the time when I was looking for the listings, and they were way too old and too expensive. I had almost given up the idea, and only by pure chance, while searching for used CPUs, I stumbled upon an interesting website in Norway, where I live. It specialized in reselling used PC components. I couldn't believe it. This was exactly what I needed. So I started shopping. Here what I picked up from that store: ASRock Fatality B450 Gaming ITX AM4, AMD Ryzen 5 2600X, Cooler Master B500 500 watts PCU, Corsair Vengeance LPX 8GB of DDR4, and the graphics card HP RTX 260 6GB. I was about $300 now. It's not a very powerful CPU or a super strong graphics card, but for what I'm going to play and how I'm going to use it, it will be more than enough. And besides, it will be a huge upgrade compared to my old white PC down there in the corner. Maybe at the end of the video I will test both systems side by side, just to see the real differences between them. So all that was left to do is just wait for everything to arrive. And of course figure out how I'm going to put everything together in one place. You probably noticed that there is no case. That's because I'm going to try to make one myself. And you're probably wondering, how? Well, I can honestly answer that I have no idea. I have absolutely no clue what I'm doing here. I never even built a computer in my life. Everything I bought here, someone could send me a pack of chips and I say, wow, what a fast processor I have here. Joking aside, I bought this thing a few months ago and I had been looking for a good excuse to finally use it. This is a Bamboo Lab P1S 3D printer. It was an old dream of mine, specifically for projects like this, of course, to buy one. Of course, I justified to my wife by saying that I will make money with it by producing cup holders or some shit like that. Well, I'm still looking for a perfect design, you know. So if you think I know what I'm doing and that I'm competent, you're very wrong. Here's the best example. You probably notice it. A standard 500 watts power supply, meaning for a normal size PC case. It never even crossed my mind that its physical size would be almost 8% of the planned case size. How did I notice it? Well, before I got all the parts, I started trying to model the case first, of course, without having any parts or idea how big they are. Well, I had the rough dimensions-ish. So when I modeled them and started testing different orientations, I was actually pretty happy with myself. Everything seemed to fit nicely, right until I modeled the PCU at its full size. That's when I realized that I made a mistake. No matter how hard I tried to cram this thing in, it just wouldn't work without increasing the overall size of the case. So I only had few options left. Since my 3D printer has 23 by 23 centimeters printing area, actually it does say 25, but I couldn't manage to remove the limitations. I know it's possible somehow. So I could either split the model case into multiple parts and glue them together. That would leave an ugly seam, and the case would grow way beyond my planned 16 by 16 cube. Or I could try returning the PCU and looking for a replacement. I'm not gonna glue any of that case. No, I hate glue. So this is where eBay came to rescue. I didn't want to spend another $100 on this computer, so I tried to find as cheap as possible alternative, and smaller of course. I didn't have to search for long before I found another PCU which is exactly at the right form factor for my build. But happiness didn't last long, because I soon realized another major flaw in my design. Cooling. Micro-ITX cases especially need a good airflow, so I ordered some fans, because apparently when you build a compact plastic cube stuffed with electronics, it turns into a high-performance air fryer, apparently. And of course the fans also needed some space. And since I have already redesigned the case so many times that I don't even know which version I am on, I ran out of filament. Again. At this point my 3D printer isn't a tool, it's a subscription service. Time to order more. When the components finally arrived, I started measuring everything so I could recreate accurate 3D models. And when I say measure, I mean measure, model, print, realize it's wrong, question my life choices, repeat. I spent an unreasonable amount of time trying to fit everything inside this tiny cube. I wanted the front and back panels to be removable, clean, simple, elegant. like I knew what I was doing, so I chose magnets. But then came the real problem, the GPU intake. I needed the graphics card to pull fresh air from the bottom of the case. That's how I designed it, and that's how I want it to be. Sounds simple, just make a hole, right? No! So the magic dance of measure, model, print, cry even harder, realize you have no more filament, repeat. This shitty hole took me around 10 times of redesign. That's what happens when a non-engineer tries to engineer stuff. So I split the entire model into multiple parts and printed them separately, which sounds smart until you realize that now you have to glue everything together perfectly straight with glue. Sticky super glue. I hate glue. Have you ever tried aligning multiple 3D printed parts while glue is drying and your hands are still shaking because you already reprinted the same part like 3 times? Yes, it builds character and anger. And yes, I had to order some filament again. Because while I was redesigning things for the 74 times, I somehow misaligned the bottom ventilation slot. Which means I successfully engineered a very stylish, very compact, but completely suffocating box. It looks amazing, it just couldn't breathe. At this stage, the project has officially transformed from creative build to man fights thermodynamics, and thermodynamics was winning. And of course, nothing could go smoothly. After taking a closer look at the graphics card, I realized something else. If I want it to breathe properly, I have to control the airflow direction. I needed a clear path in one side, out the other. Luckily, this HP RTX 2060 has a cooler design where the air moves horizontally along the length of the card. That actually worked in my favor. For once, something cooperates. But then I noticed something I really didn't like. The rear I/O shield of the card. It's designed for a normal, much longer PC case, which means not flat. It has this awkward L-shaped extension that sticks out. So I had 2 options: redesign the whole case or remove the I/O shield and fix it. Which of course means partially disassembling the GPU. I would have to separate it from the cooling plate. Now normally that sounds terrifying, but I have no idea what I'm doing, so it doesn't faze me at all. But when you think about it, this card is 7 years old. I seriously doubt that thermal paste was ever been replaced. So opening it might actually be a good thing. So that's what I did. When I finally took it apart, I was expecting to find fossilized thermal paste. Something dry, cracked, turning into dust. But surprisingly, it wasn't that bad at all. Which raised 2 possibilities. Either someone actually took care of this card and replaced the paste not too long ago, or it simply wasn't used very heavily, meaning the paste never had to endure constant thermal cycles that would try it out. Both options were good signs. Still, replacing it will only help. Fresh thermal paste means better heat transfer, better temperatures, and fewer reasons for this tiny plastic oven to catch fire. So that's the plan. First, I deal with this ridiculous rear I/O shield. Then I repaste the GPU. Then we pray that the thermal don't turn this entire project into modern art. Because at this point, I'm not just building a steam machine anymore. I'm rebuilding a 7 years old graphics card while redesigning the case that barely tolerates its existence. Alright, The GPU was ready. All that was left was to wait for the PCU, which, judging by shipping speed, was probably arriving by horse. So while I waited, I finally finished the final version of the case, and I could finally start printing and assembling it, gluing it, super glue specifically. And to be fair, super glue works extremely well with PLA. It's less adhesive and more chemical welding. So I thought, why not? The hardest part will be aligning everything perfectly, because once that glue touches, you maybe have a second to adjust. After that, it's permanent. And slightly movements and misalignment, and congratulations, you just created another part to print. There was just one small issue. My new filament still haven't arrived. So naturally, instead of waiting like a rational person, I started printing and assembling parts anyway. Because patience is for people who don't own a 3D printer. I did have some PETG filament in different color. It's stronger than the PLA and handles higher temperature better, which, considering I'm building a compact heat chamber, isn't exactly a bad thing. The only downside is it's gray, not the color I wanted. So now my clean, cohesive design had random gray structure components hidden inside like some kind of mechanical skeleton. But I figured most of it won't be visible anyway. Structural pieces don't need to be pretty, they just need to survive. So I printed some internal components in PETG. Stronger, more heat resistant, slightly uglier. And once the correct color filament arrives, I will finish the visible exterior parts properly. But of course, right in the middle of assembly everything, I had a thought. Maybe I should test those components first. I mean, the project is almost finished and I still haven't actually seen this computer working. Every single part I bought is used. And yes, the website does say everything is tested and verified, but that's the kind of reassurance that sounds great until it's your project on the line. So I decided to do a quick test bench setup. Now keep in mind, I was handling ultra sensitive electronics with my bare hands. No static wrist, no grounding, nothing. Because apparently I decided that static electricity is a myth. A conspiracy invented by motherboard manufacturers. In reality, I was basically speedrunning how to destroy a PC in one easy step. But somehow, it posted. That beautiful little bio screen appeared. And I'm not going to lie, that moment felt like I had just defused a bomb. Used parts, unknown history, my questionable handling, and yet it worked. No sparks, no smoke, no financial regrets. So, with the system officially alive, we can continue building this cube. Now it's no longer just a pile of second-hand components, it's a functional organism. And I'm about to seal it inside of a plastic box I designed it myself. What could possibly go wrong?
Just joking. It's my smoke machine.
First of all, my brilliant idea of keeping the front and back panels easily removable with magnets completely failed. The magnets I used were simply too weak to hold the front panel properly. They were barely strong enough to keep the front panel in one place, and that was before I added the fan on top of it, so I realized that design would need to be modified. Modified, not redesigned. We are not going back to the version 1. Thankfully, I only needed to print few small support pieces, little structural helpers to reinforce the front panel. This way it would be still removable, still clean, still without screws, but no longer held together by optimism. Of course, installing the fan also required some modification. I didn't have screws small enough for this setup, and gluing a component that could fail someday didn't feel like a smart long-term decision. I may ignore static electricity, but I do have standards. Oh, and after about 20 prints, I finally learned how to properly use my 3D printer. So that's progress. Expensive progress, but progress. That said, I'm still not fully happy with the front panel look. These corners are bending upwards, which doesn't look professional in my opinion. So there's a very high chance I redesign it again. Because at this stage, changing the design is basically part of the workflow. So the horses finally arrived and they brought me my new PCU. And now comes what I believe will be the hardest part, the back. Because the back panel has to fit everything. Motherboard I/O, GPU outputs, power connection, and airflow. While I'll wait for my printing filament, I will try to design the back as good as possible so I don't use so much material and waste it. So I spent a couple of days just messing around with the back, measuring, modeling and modeling. I didn't need to wait long until my shipment of new filament has arrived, and finally I can finish this project. I actually had quite a lot of trouble with the back, because the holes didn't line up the way I wanted to. So I tried using PETG, which I had quite a lot to print, and then when I was happy with the fitment of all the holes, I just printed with PLA. Of course, there were some minor parts that I needed to print, so I did, and these are the legs. I like how the legs came out, and they look pretty awesome in my eyes. But of course, while printing the back, I had some trouble with the printer and the back didn't get finished the first time. But actually it was a blessing in disguise, because I saw that the holes didn't line up just right, so I printed it again, and this time the last time. I wanted the front to be customizable, the same way as original steam machine is. So I updated my design, used a little bit more magnets, and it came out awesome. So there's only few things left to do. I had this few veneer pieces lying around, and I thought they will be perfect for my design. I chose one and decided to glue it on front. And what I like about this design is that I always can change the front panel wherever I want. So maybe in the future I will just print some panels and redesign. The only thing was left to do is install Linux and enjoy my new system. I spent almost a month on this project. I'm very happy how it came out, actually. I will eventually change some parts because I don't like the front and I don't like the top. But all is left to do is just enjoy the machine. I didn't want to make this video very long, so I didn't have enough time to make a comparison between my older machine and the Steam machine that I just made. So maybe that's an idea for future videos. Leave a comment if you want to see a comparison between those two machines. So thanks for watching. Hope you enjoyed this project of mine, and if you would like to see more projects like this, or you like old school gaming, or you like what I do, please subscribe and wait for more videos to come. Thank you for watching and see you another time. Peace.